I was trying to think, would this be something that would actually be useful for fuel efficiency? Would it be the best for fuel efficiency if something accelerates at a constant acceleration, and then you could just, you get into your vehicle, you get onto the highway, you just pre-program, I want to get to 100, and then a computer system automatically takes a constant rate of acceleration so that your fuel efficiency is best over that amount of time, and you get there in 20 seconds. 20 seconds seems a little bit, is that 0? That's pretty slow, isn't it? Like, you know, the fastest ones are like 0 to 60 in...
You can get, well, Bugatti does it in 2.5.
Yeah, now that's insane.
My SUV does it in 5. But that's modified.
Yeah.
So that's...
But you know Nathan, he likes to take things slow, so this is... 0 to 60. This one's 0 to 60 in 20 seconds. So he's going slow.
It gets 0 to 100 in 4 seconds.
I just said 2.5.
But you said 60.
All right.
100 miles an hour in 4 seconds.
Trying to beat the true master. Cars.
So again, we're going to use this same idea, displacement, velocity, acceleration. We're trying to find out how far he actually went in 20 seconds. He wants to get to 100 kilometers per hour. What's going to make this question a little bit tricky is we're dealing with different units. This speed is in kilometers per hour, and here we're dealing in seconds. So we're going to have to work with those different units and think about that all the way through. But what do we know? Okay? What does it mean if it increases its speed steadily? Constant rate of acceleration. So our acceleration is some constant. Let's call it k, because we don't know what it is. So we know, though, that our acceleration is k. And what units do you want to use? We've got kilometers per hour here. Question says in seconds. Okay. Kilometers per second?
It says right there, meters and seconds.
How far in meters and seconds? So we'll change everything to meters and seconds. So we'll say his acceleration is meters per second.
One question is, how many kilometers do you go if you're going 60 kilometers an hour in 1 hour?
Wow.
Oh, 60 kilometers an hour in 1 hour. Well, I can usually run a mile
You know, some tires.
in about a day, and that's when I'm really booking it. Okay, so what does this mean for our velocity? Our velocity will be kt plus c, because we can integrate to go backwards. What's c? Well, we can say what speed are you going when you're starting? When time is 0. When time is 0, your velocity is 0, because we're assuming it's going to increase its speed, so you're starting at 0. So then that would mean that we just have our velocity is kt. Are we given any other information about velocity?
Gotta go to
100 kilometers an hour in 20 seconds. How do I write this in? If I put 20 in there, and you're telling me meters per second, what do I put in here for velocity? 100 kilometers per hour is how many meters per second? Divide by 3.6?
Yes.
Really?
Option slowest 0 to 60.
And how do you figure 3.6? You just memorized it?
Well, because if you go like, if you put kilometers over hour and per minute, right? You see that it's 100 kilometers and then it's 3,600 seconds.
1,000 meters, right?
Yeah, and then you have 36 at the bottom.
And there are
5,000 feet.
3,600
Yeah.
seconds. So if you divide by the 3.6, what do you get? What's the number? What value do you get?
Oh, you get 27.7 repeating.
27 and 7/9?
Yeah.
Last time I figured this out, I changed everything to hours and minutes, and then the mental math is a little bit easier. But we'll keep it with this. So 27 and 7/9 meters per second, that would go here, because that's our velocity. So what's k?
Oh, well.
25 over 18.
25 over 18. So divide both sides by 20, and then use that fancy thing on your calculator which changes the decimal back to a fraction. Does everybody know how to do that on their calculator? So if I had 27 plus 7/9, that's 27.7 repeated. If I divide that by 20, I get 1.38 repeated. You can hit math, fraction, and you get 25 over 18. That's a pretty nice value of k. Now we know that our velocity formula is 25 over 18 t. We want to find out how far he's gone in 20 seconds. So we can integrate again. This will be t squared over 2 plus d. When time is 0, how far is your car gone? 0. So d is 0. And we've got that s is 25 over 18 t squared over 2. Plug in 20. And we can plug in just 20 because we're already dealing in seconds. And we can, our answer will be in meters. How far have you gone?
No, wait, what?
And this one you could give me a decimal. 277.7 repeating. That's pretty brutal. 20 seconds. His vehicle's only gone a quarter of a kilometer. And this would be meters. Pretty fast car. Hi. I have to admit I made this question up on my own. I chose 20 seconds. If I did it again, what should I choose? 10 seconds? 5 seconds? How many? 5 seconds from 0 to 100? 0.3 seconds, make a really fast car. But again, when we look at what we just figured out, given the information that we had, that's, I don't know, I think that's pretty cool. Like all we were given was a constant acceleration, took 20 seconds to get to 100 kilometers per hour, and we can figure out that vehicle will have traveled 277.7 meters. There's an easier physics formula?
No, I don't know.
There probably is. Anytime you can figure something out, you can create a formula that says, well, put in v, put in t, and then work your way out to the end, and here's the formula. You can just plug it in once. If you wanted to, we could do that.
You